Bienvenidos, Ushamadid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy ITNv7 course curriculum, and in this activity we're going to be completing a modified lab that would typically be done if you were taking the course in an in-person format. In other words, this is a lab you would be doing with a rack of equipment, but what we've done is we've modified this lab and we've made it so that you can complete this activity in Packet Tracer. So let's go ahead and dive into a blank canvas. And again, we're going to be creating a network from scratch here, and we're going to include a router and a switch. And so you at home who may or may not have the lab can follow along as I add components in and the values that I put in. And so again, the first thing we're going to do is we're going to add two PCs, and you can see we've got PC A, and I'm going to enlarge this in just a second, so hold on. And then we've got PC B over here on the right hand side, and then we're going to have a router. And for the router, let's go ahead and choose a 4221, and that's what the lab is calling for. And you'll notice I don't see the 4221 down here, so let's go ahead and grab a 4331. Again, we want to make sure we're running that iOS XE. So there's our 4331, and let me make sure that I get this in the right location. It's going to be over here toward PCB. And then we're going to grab a switch. Now the switch that they recommend is a 2960 with 15.2 code. So for that, remember, we have to go into the folder here, and I'm running Packet Tracer 731, and we grab the 2960 out of that folder. Now, that's not going to have 15.2 code on it, but if we go to the CLI, we're going to be about as close as we're going to get, and that's going to be the 15.0 code, 15.02 SE4 code, which is going to be good enough for what we're doing. All right, so now that we have all the devices out onto our canvas here, let's enlarge things. Now on a Mac, if you're curious how I'm doing this, I'm holding the Command or the cloverleaf key down and pressing I. And each time I press I, you can see that the topology or the icons grow a little larger each time. Whoops, let's try to bring these guys back to the center here. And let's enlarge it a few more times. And there we go. A little easier to see what we're working with here. All right. Now, one of the recommendations that I give to my learners is we've got these things out here. Nothing's been configured yet, but why not save the file as we're going to be instructed to save the file here shortly. And I'll just drop it into my downloads folder. And so I'll go ahead and say lab 10.4.4. I'll put my name in here. Travis B, maybe today's date, 2/14/2021, and then I save it, right? Because if your Mac crashes or your PC crashes or Packet Tracer crashes, right, you want to make sure that you've got a backup copy or a saved copy of this activity. So now let's connect these devices together. And this is something that we've been doing on our Monday evening Zoom sessions. So I'm going to use a straight through cable, and we're going to come up, we're going to connect from the Fast Ethernet interface on the PC over here to Fast Ethernet 06. And then we're going to go from Fast Ethernet 05 on the switch over to Gig 001 on the router. And then we're going to go from Gig 000 on the router over to Fast Ethernet 0 on the PC. Now, the router interface by default will be shut down. The switch interface by default is going to be up and operational. So I'm going to give myself a little bit more room with which to work here, and we'll try to straighten these lines out here, and there we go. And so that looks a little bit better. Right? So now we have sort of a basic switch network. Again, we've got these red upside down triangles on either side of the router because by default, the router interfaces are down. If I mouse over, and let me bring that back, if I mouse over this ISR 4331, you can see that the links are all down, right? Because they've been shut down. However, if I mouse over the switch, you can see that if you look at Fast Ethernet 06, you can see it's up, right? Because by default, the ports on the switch are up, but both sides need to be up for us to get these green upward-facing triangles. All right, so we've got the addressing table at the top of the activity, and that's where I'm going to start. So we're going to go ahead and we're going to add in all of the IP addressing information we need for each of these devices, including changing the display name that you see here, right? Because PC0 is actually PCA, switch 0 is actually switch 1, and then router 0 is router 1, and then this PC1 over here is PCB. So let's make those changes, and we'll just deal with the router first. So we take a look at the physical setup of the router here, right? And we see we've got what appear to be 2 Ethernet interfaces, and it's pretty tough to see in there. We've got 2 open network interface module slots here that we could add in NIM cards. That's what that NIM stands for, Network Interface Module. We can add in additional connectivity. We don't need to do that here. So the configuration, the display name, I want it to be router 1. Now I can even drop the host name in here, because what that does when you enter the host name here is that it is basically doing the global config work for you with the host name command. And then we'll run that again just for good measure. So let's go ahead. We'll bring this down. We're going to extend these out here so we've got some room with which to work for each of these devices. And so you can see what happened was it ran the hostname R1 command for us. And that's how we would set the host name on the device. All right, so to the addressing table, right? Let's take care of this first. So it wants us to configure interface gigabit Ethernet 000. Now we know that that's the interface that is connected to PCB. And so let's go ahead and put in the IP address on this interface, which is 192.168.0.1, and it's a /24, meaning the first 24 bits, and in each octet, if each of the bits is dedicated to the network, that bit would be on, and then we would add those values up, and we know that if all 8 bits are on, the value is 255. And then in the last octet, because none of the network bits have been borrowed, or I'm sorry, none of the host bits have been borrowed for network bits, we leave it as 0. Now it also is going to introduce us to some IPv6 addressing information. So IPv6 address, and I'm going to start with FE80::1. Now if I hit enter here, we're going to receive an error message, right? It's going to come back and say, hey, incomplete command. And the reason for that is that the FE80::1, that is a link local address, meaning it's only significant and only has value on that link right there. We can't route these link local addresses. I can't advertise these link local addresses in a routing protocol. And that's why they're referred to as link local. So as the name would indicate, and by definition, it is only relevant on the link on which it is configured. Now, this is different from the global unicast addresses. So if I say IPv6 address 2001, that is in the global unicast range. So DB8:ACAD for Netacad, and then ::1/64. And so this is sort of our first foray from an activity perspective into that IPv6 address space. Now, the /64 at the end, that is not a subnet mask length. That is the prefix length. So with IPv6, some of the naming conventions are going to be changing, right? So we've got this link local address here that we're using, that FE80::1, where we have to identify it as a link local address. And then we've got this /64 at the end. And a lot of learners ask, well, why can't I just simply do with IPv4 addresses, put the IPv4 address in, and then put a /24? So they want you to learn how to do it using the dotted decimal notation in the subnet mask, as opposed to just putting the slash in there. So the slash here is the prefix length, right? It is not a subnet mask. It's a prefix length. And that is the full command right there. So the reason I'm doing this up front as well is I want you to see that we don't have to enable IPv6 unicast routing to put IPv6 addresses on the interfaces. So pay attention to that, right? Again, I don't have to enable IPv6 unicast routing in order to put IPv6 addresses on interfaces. So let me go ahead and say no shut. And you can see that our arrows there moved into the up position. Try to straighten that out a little bit. The arrows here moved into the upward facing green position, meaning that the interface is no longer shut down. So let's also go ahead and go into interface Gigabit Ethernet 001. Now we know that this is the interface facing the switch over here, which is going to be switch 1. Currently we see it as switch 0. So let's no shut the interface right out of the gate. So as we're configuring things, we'll allow spanning tree to do its work there. That's that orange dot we see where we're now in the listening state, and then we're going to go into the learning state, and then eventually we're going to go into the forwarding state where we'll have a green upward facing triangle. So let's get these IP addresses on here as well. So this is going to be 192.168.1.1. Now, this is what I was referring to. A lot of learners request, hey, why can't I just do that? Well, if I do that, you can see that it thinks it's part of the IP address. So again, we want to learn how to do it with the dotted decimal notation, even though the addressing table shows that /24, meaning in dotted decimal notation, our subnet mask is 255.255.255.0. And I'll hit enter. Now we've got two IPv6 addresses. So IPv6 address FE80::1 link local. Now, you might be thinking when I hit enter here, you might be saying, well, wait a second, you put that same link local address over here on the same router on a different interface. And with IPv4 addresses, I can't do that. I can't come up here and put 192.168.1.1 on both sides, on both interfaces here. It would say it's overlapping. We'd get an error. Remember, by definition, link local means it is only significant on this link, on this segment here between PC1 and PCB and router 1. So with link local addresses, and this is a best practice for router 1, is that I would use the same link local address. Again, when applicable, if you're hooking up to another router and it's already using, let's say, FE80::1, you can't do that. But here I can, right? Because we've only got router 1. So use the same IPv6 link local address on each of the interfaces on router 1, because then you always know what the link local address for any interface on router 1 would be. Again, only significant on that link, which is why I'm allowed to use the same link local address on every link on router 1, because it's only significant on that link. All right. So enough of hammering that. But again, that causes a lot of confusion with learners who see this and say, well, that doesn't make any sense. You're putting the same address on multiple interfaces on the same device. You can't do that. However, with link local addresses, we can. Now, with the global unicast address, db8::1:1/64, again, link local addresses, that's a different story, right? Now, when you look at the link local addresses I added here, notice I said :1::1, but up here I just said ::1. Why didn't I put a number in here? Why didn't I say ACAD : and let's get our ink to go drawing tool out here. Why right there did I not say :0? Because obviously this hextet right here is reflecting the third octet value. You'll notice we say :1 and it was 192.168.1. So for this hextet, why don't I put 0 in here? Well, I could have put 0 in there, but why waste my time? If you don't put a value, it is assumed that the value is 0. So think of it as the default, right? A tricky Cisco kind of default mentality. And again, this isn't a Cisco thing, right? But I'm just kind of tying it to, if I don't put it in there, then we get the default, right? Which is going to be 0 in that IPv6 address. So, and literally in this hextet that we would be talking about, right, that is equivalent to that hextet, it would be 0000, right? Not just 10, but it's all zeros in there. All right, so that is our IPv6 address on that interface, and let's go ahead and indicate that this is an address. So there we go. And we already said no shut at the beginning of the activity, so we can see that everything is up. So that's good, right? So this is a good start, but let's think of some other considerations here, right? Some considerations that in lab 10.1.4, or I think it might have been 10.4.1, the lab that preceded this one, I kind of moved by a little quickly, right? Or I actually didn't implement. So let's say no IP domain name. Whoops, IP domain name. Whoops, domain name lookup. I was typing the wrong key there. Domain name lookup. Let's get into line con 0 and let's say logging synchronous. Again, the no IP domain lookup means if I mistype a command in privilege exec mode, it's not going to try to resolve it as a host name, right? And then the logging synchronous, if we've got a bunch of output coming to the screen, then we're okay because I'm going to get my prompt back from where I left off. All right, so now let's type in end and let's say write mem. And let's move over to our switch. And same thing here, let's give ourselves some room with which to work. Right, so we can see everything here. And I'm going to go to take a look at the physical, right? And we can see the physical layout here. If I go to the configuration layout, I can say S1. And we can jump ahead, right? And you could even put in a serial number. You can, we jump ahead here by having the hostname command applied, right? Because we're pretty safe with that. So now the switch is displaying the right information. The router is displaying the right information. And let's go ahead and start out with no IP domain name lookup. And let's go into line con 0 and let's say logging synchronous. And then let's get our switch virtual interface configured. And I'm curious to see here, we might have a conversation about templates. Because on Cisco switches, there are various templates that exist. And let's see what happens when we go to put on our IP addressing. Now, again, we're working with VLAN 1, the default VLAN. A VLAN is a broadcast domain, is a subnet, right? So we're going to go into interface VLAN 1, that switched virtual interface. And we're going to put our, and actually, I'm sorry, I was looking at the addressing table wrong. There is no IPv6 address we'll be using here. So we'll simply be able to put IP address 192.168.1.2. And again, it is a /24. It's keeping things easy here from a subnetting perspective. And finally, we want to say no shut. So from here, I should be able to ping this interface on the router. So let me say do ping 192.168.1.1, which is the default gateway. And let me pull this up a bit here. That interface right there on this router is the default gateway for this subnet over here. Remember, this is the 192.168.1.1 subnet over here, which happens to be VLAN 1, and that's the only VLAN we have configured on our switch. What command could you use to see that? Exactly, I could say do show VLAN brief. And here it is. VLAN 1 and all of the interfaces by default are member interfaces in the default VLAN 1. When you look down here, these are all legacy for Token Ring, FDDI, and you'd be hard-pressed to find networks today using these technologies. Again, they're probably out there somewhere and probably in a government implementation somewhere. But again, those are just kind of legacy leftovers from days far past. So all of our interfaces are in that VLAN, or in VLAN 1, the default VLAN. So I can ping this interface here, right? So if I hit the up arrow, I can ping the interface on router 1 that is here. But now I'm going to try to ping the interface over here, right? Remember, we IP'd that interface as 192.168.0. 1. And let's see what kind of success or failure we have when we go to ping that interface. And you can see that it doesn't work. And my question to you is why? Why is it not working? I mean, we're directly connected to router 1 right here with this connection right here. So why is the packet not making it over here? Or if it is making it over here, why is it not making it back? And the answer is it's not making it over here. Because when we type this command, remember, this is not transit traffic. Transit traffic would be traffic that comes from the PC through. It transits through the switch over to the router. Or would be coming from the router or other devices beyond the router over here through the switch. That is traffic that is transiting the switch. This is traffic I am generating from the switch. In other words, when I'm pinging or telnetting or SSHing from the switch, that is considered to be control. I want you to think of it as control plane traffic or management plane traffic, right? It's traffic that's being generated by the device. And in that context, the switch is just like a PC. It needs a default gateway. It needs to know where to send traffic for networks that it is not aware of. And it's a layer 2 switch at that. So when I say do show IP interface brief, you can see the only layer 3 information it has is for this VLAN, for this subnet. It is not connected to the 192.168.0, nor does it have a route telling it how to get to the 192.168.0. And this is why the traffic is failing. So what do we need to do? Well, we need to put in a default gateway. Very critical here. IP default gateway 192.168.0. I'm on the right side there. Hold on. Dot 1.1. And so that is going to be the default gateway for switch 1. Again, this is not implying that switch 1 can now magically route traffic. This statement causes a lot of confusion with learners. They see that and they're like, oh, okay, so any transit traffic that shows up here, switch 1, if it doesn't know what to do with it, is going to forward it to router 1. Not for transit traffic. It is not routing traffic. We are simply providing this device, just like we provide the PC a default gateway for traffic the PC is generating. We're providing a default gateway for traffic that the switch is generating, not transit traffic that's just passing through the switch. So now, with the default gateway setting, if I say do ping 192.168.1.1, can I get to my default gateway? Well, we already proved that. Can I get beyond my default gateway? I can. And this might lead you to your next question, right? Inquiry and inquisition is a great thing in the networking space. And if you're thinking to yourself right now, well, that's great. You just explained that we've got a default gateway and now the traffic can get here. But if I look at the router has no default gateway. If I say show IP route, my gateway of last resort is not set, which might lead you to ask the question, well, then how can the router get the traffic back? How does it know? Remember, the router knows how to get the traffic back because it is directly connected to the source network or the source IP's network from which this ICMP echo request is coming. 192.168.1. What's the switch? .2, right? So that network in the source address field, right, in the IP packet or the ICMP packet, we've got a source address. The router knows how to get there because it's directly connected to that network, right? With the switch, and when we treat the switch and treat it as a PC when we're generating traffic that's going to originate from the switch. We need that default gateway statement on there. Now, the router may have a default gateway as well, but it is not relevant in this configuration because it's directly connected. It doesn't need to know a last resort, a Hail Mary to send the traffic to, because it's directly connected to where it would need to send this reply, this ICMP echo reply. All right. So now let's go ahead and finish what we started here on switch 1, and that is simply going to be to write the configuration out, right? To save the configuration, the running configuration, where? Where does that running configuration get saved? Right, it gets saved as the startup configuration, and it gets placed in non-volatile random access memory, meaning if I save the config and I reload the device, what we just did is saved, because when the device boots up, it will take that startup config from NVRAM, from non-volatile random access memory, and it's going to pull it into the volatile random access memory, or just RAM. It's going to pull it into memory, and we run it as the running config. So if I said show run, and we come down here, there's my interface VLAN 1 config, there's my default gateway config, there's my logging synchronous. Further up, we saw the no IP, and where did that go? Or did we do that on the switch? I thought we did that on the switch. But what we should have seen on the switch is no IP, domain, domain name lookup, and we didn't see that. Let me make sure. Yeah, that's funny, the switch is not, give me 1 second here, let me see if it's going to be no IP domain name lookup. Let's see if it wanted that. Yeah, oddly enough, and again, maybe it's a packet tracer thing, maybe it's a layer 2 thing, but we can actually check to see, and actually I can't right now, the switch is off. I was going to check on a real Cisco switch to see if that is the behavior that we see there. I've never noticed that before. So again, our switch is fully configured, and now let's move over to PCA. And so again, the config, we're going to change this to PC-A. And we can do some address setting in here, right? Like the default gateway, things like that. But I'm going to come to the desktop, and we're going to get it all done in one spot, right? So what is the IP address of PCA? Well, it's 192.168.1.3. Now, I hit tab, and we auto-magically get the correct setting for the subnet mask, because 192, if we're talking about a classful context, would be a class C address, and it would be a /24 by default. Now, here's our default gateway setting, which is going to be the same as the switch, right? 192.168.1.1. We're not concerned about DNS. Now, pay close attention to PCA, because we are going to be adding an IPv6 address to PCA, DB8:ACAD:1:3. Again, the hextets here, and then again, the value at the very end correspond to the 3rd and 4th octet of the IPv4 address, right? Now, some may argue that, maybe this isn't the best thing to do, but it certainly makes it easy for us to kind of keep track of, oh yeah, what's the end of that IPv6 address? Now, you'll notice that we had this link local address auto-magically generated for us. And let me ask you, would you like to have to remember that link local address or this link local address? FE80::3. Now, the addressing table doesn't show that setting, but I would again highly recommend that you change from the default EUI64 generated, right? And we'll talk about EUI64 generation of link local IPv6 addresses as we move through the course. But that's that value that you saw there, which was crazy. You're not going to remember that, but it's globally unique, and that's why they chose to use that approach. However, in our network, we know that we can get away with FE80::3, so we'll do that. Now, what would be our IPv6 default gateway? Is it going to be that 2001 global unicast address here? And the answer is no. We're going to use the link local, FE80::1. So let's go back to the desktop. Let's go to the command prompt and let's go ahead and see, can I ping 192.168.1.1? Can I ping my default gateway? I absolutely can. Can I ping FE80::1? And I can. I can ping the IPv6 default gateway. What about that global unicast address, db8:acad:1:1:1? So I've got full IPv6 reachability here. All right, the last thing to do, and let's bring this down here and give ourselves a little bit more room with which to work and to see what's going on. Let's come over to PC1, which is actually, in our diagram, going to be PCB. I'm going to go to the desktop, and that way we can knock it all out in one shot right here. So PCB is 192.168.0.3. Whoops, sorry. And I got a typo in there, 192.168.0.3, and we automatically get that /24. And we know, again, we're on this broadcast domain over here, this subnet. Layer 3 devices like routers separate broadcast domains. They separate networks from one another. That's the job of that layer 3 router, in addition to routing packets, but it breaks up broadcast domains. So we're with PCB here. So on this side, 192.168.0.1 is the interface. Let me double check that. Yeah, of the router. No DNS server to worry about. Static IPv6 address, right? So what do we want for PCB? It's going to be 2001:db8:, ACAD::3. Again, I don't need to put the 0, but what if I did this? 0::3. Is that going to work? Absolutely, that's going to work. Do I have to put that 0 in there? In fact, I could have done this. I could have done that, and it's still going to work. But again, why do that when you don't have to, when it's implied that that is the value for that hextet in there? All right, link local address. Again, do you want to have to remember that's the link local address of my PC or FE80::3? Again, we're probably not going to use that link local address on the PC, but this is a good habit to get into so you don't end up with those crazy EUI64 generated values. So let's kill the IP addressing screen, and now let's confirm here. So can I ping 192.168.0.1? And the answer is absolutely we can. What about ping FE80::1? Again, the link local address of this interface on this segment, right? This link between PCB and router 1, is that going to work? And it does. What about that global unicast address we assigned? :ACAD. And again, I could even in the ping command, right? Or I could do 3 zeros and then say : :1. Let me make sure I got the right address. And it works, right? So those zeros that are in there, yeah, you can have them in there if you want. But again, there's no need to put them, let's get rid of that, no need to put them in there because it is assumed in an IPv6 address, if those zeros aren't in there and you've got nothing in there, that's what's there. Remember, 128 bits, if you've got a hextet with all zeros, then you can zero it out. And I'm saying hextet because each hexadecimal character is 4 bits, right? Each hexadecimal character is 4 bits. And so if there's 4 hexadecimal characters and each one is 4 bits for a total of 16 bits, I would refer to that as a hextet. Okay, so we've got PCB configured. So now what we're going to do is we're actually going to dive into the steps inside the activity. So, and we've done a lot of these already. Cable the network up. We've already cabled things. We've powered everything on. If there was an existing config, what would we need to do? Well, we would want to go ahead and erase the startup configuration, reload the device, and start from scratch. So configure the devices and verify connectivity. We configured all of the IP addressing, no Windows firewall considerations. And so now what we're going to do is we did some configuration work on the router. We entered the host name. We disabled DNS lookups on the router from attempting to translate things. And so now let's get to what we really want to get to, and that is our privilege exec configuration here on router 1. Because as you can see, I hit enter, the console line auto-magically lets me in the user exec mode. When I type enable, I go right into privilege exec mode. So we're going to take care of this right now. So we're going to set the enable password or the encrypted password or the secret password for router 1 in addition to some other settings. And so we're going to say enable, and it wants the privilege exec password, right? Enable secret to be set to class. Now it's asking us to also put a password on the console line. So let's go into line con 0 and we're going to put in Cisco. And it wants the same on the VTY lines, the virtual terminal lines. If I say do show run, we should see 5, 0 through 4. So I'll say line VTY 0 through 4. And it wants us to put the password on here. Oh, and we got to enable login, sorry. And so password Cisco, and then we say login. And I was wondering if they were going to walk us into the issue or the thing we should have ran into, which is we forget in the console line to say login, right? Oops, and I forgot the password even. So we'll say Cisco and then login. So you can see what happened there. I tried to say, oh, force the user to enter the password on the console line. And if the password's not configured, then Cisco iOS is smart enough to tell you, hey, you need to set the password. And in fact, until you do, you can't log in. So if I had logged out after I said log in on the console line and not set the password, I would have been locked out of the device, right? So be careful about that. All right, so I've got my password in there for the console line, the VTY line, and we're going to go back into line VTY 0 through 4. And if I was to say do show run, you can see that we don't have any indication here as to what types of connections I might accept. With a console line, it's a foregone conclusion because we're using a console cable, a rollover cable, and we're trying to get logged in. Here with the VTY line, am I telnetting in remotely? Am I SSHing in remotely? How am I getting in? And so that's what this next command is all about, the transport input command. And what you can see here with the transport input command is I can pick all, meaning allow all protocols. I can say none, meaning allow no protocols, or I can specify SSH or telnet. So let's see what the default might be, at least from Packet Tracer's perspective. So if I say transport input all and say do show run section line VTY, again, I'm filtering the output of the do show run command so that it only shows me the VTY section. And so it's interesting. I said transport input all, and then when I run the command to show me the running config, it doesn't show anything there. So what might that lead you to believe? Yeah, if you're thinking, hey, this is leading me to believe that it is the default. Well, let's check. What if I said transport input none and then said do show run, and here it shows transport input none. So all is looking pretty good as our default right now. Now, what is the activity asking me to do? It's asking me to change it to telnet for right now, right? Because we haven't gotten to the SSH portion of the course where we're going to be generating some keys, doing things like that. So we'll just leave it at telnet, right? So now we say do show run section line VTY, and it's telnet. So all would have been allowing all protocols to connect. Here, we want to get in the habit of setting it, and it's showing us initially how to use it with telnet. However, we would change this in the real world. We would definitely change that to be SSH. All right. The next thing it says is encrypt plain text passwords. Well, that's a service that the router can provide, and service password encryption. And the service is it can encrypt our passwords for us, right? So service password encryption. In fact, real quickly, and again, I know I hammer on this a lot, but this is, and we can actually look at that VTY line. You can see that the password is in plain text. If I say service password encryption, And then we go back and take a look. Again, we get a type 7 password, right? This very weak Vignere cipher. Excuse me. However, remember, Cisco is clear. The reason it does type 7 passwords, or it still supports that, is it's the shoulder surfer it's trying to prevent from looking over your shoulder and saying, oh, well, the VTY line password, Cisco, I'm going to get in easy, right? So that's why they use the type 7. All right, so create a banner that warns anyone. So we're going to say banner, MOTD, and if not authorized, please log off now. No privacy is implied. All right, so that inside the double quotes is going to be my banner MOTD message. So we're going to configure and activate both interfaces on the router. We did that, and it wants us to put a description indicating which device is connected to it. So let's go ahead and do that. So if we remember correctly, and this happens to me all the time, I can't remember which side is which on the router. So I'll say do show IP interface, excuse me, brief. And let's get into int gig 000 first, which is that 192.168.0.1. Now you can also come up here and mouse over, and it will show you the interfaces. And gig 00 is over here with PC. Whoops, over here with PCB. So in int gig 00, and this is a great, good best practice to get into. And this is going to be interface, and actually let's interface connected to PCB. And you can even put your name in here, right? Or initials, and maybe the date you did it on, 02/14/2021. And then maybe even the CCR number, right? If this is change control 8675309, and that you were doing something to your production environment. Because now when someone comes in and they say do show run, and they get down to this interface, they can see, oh, okay, so Travis must have done this. He did it on Valentine's Day. And I can reference that CCR in my change control system to see what it was he was thinking when he did this. Why were we doing this, right? Did our boss ask us to do this? So always a good idea. And then let's get into interface Gigabit Ethernet 001. And we're going to drop, and I can again pull the description up here. If we wanted to leave everything else the same, I could say connected to switch 1 PCA, right? Now, technically, I'm sure they're asking just the device it's connected to say it's connected to switch 1, but you could put PCA in there, or you can put in, this is typically what I do, so I'll say switch 1 fast Ethernet, and what interface? It's fast Ethernet 05. So I'll say fast Ethernet 05, so that you know, and we'll change that, fast Ethernet 05. So we know the switch interface by looking at the router. I can tell you, and maybe you even put the rack number. If you're in a large data center, you have no idea how many times I've had individuals call me and say, hey, what rack is that device in? And if you get onto the router that's connected to the device, right, the switch, you could, if you keep track of that information of what rack number the device that's connected to the router's in, you can easily figure out, oh yeah, it's in rack 52, right? So again, some things to think about when you're filling your description field out. All right, so now we're going to be enabling IPv6 Unicast routing. Because let me ask you, if I was to come over here to PCB and try to ping 2001 : let me slide up to the addressing table here. Let's try to ping 2001 : DB8 : ACAD : what's PCA? 1::3. If I was to try to ping the IPv6 address of PCA, and again, we can confirm that by coming over here and looking, and you can see it's 2001 DB8 ACAD : 1::3. Excuse me. If I'm pinging that, we kind of have the same problem here, right? Where PCB knows that its default gateway is router 1, but router 1 doesn't seem too interested in routing that IPv6 traffic. So if I say do show IP route, this shows me the IPv4 information, right? if I say do show IPv6, or I'm sorry, do show IPv6 route, this shows me the IPv6 routing information. Now, you might be looking at this saying, whoa, hold on. With IPv4, you said the router knew what to do because it was directly connected. Why isn't it doing that with IPv6? Because right there is the subnet to which that PCA is attached. So how come it works for IPv4, but the router won't route it with IPv6? And again, this is one of those settings. It's the same answer I give learners with, why is the auto cost reference bandwidth with OSPF 100 meg when there are hardly any 100 meg interfaces laying around anymore, right? They're still out there, but again, why haven't they upgraded that value to be like 1,000 megabits a second to reflect 1 gigabit per second? And the answer is this was just the default that Cisco decided to go with. And so in order for the router to be enabled to route IPv6 traffic, we must turn on the little Unicast routing engine inside router 1 that will accommodate the routing of IPv6 information. Again, one of the reasons I believe is that IPv6 is not very prevalent still yet today. I mean, there is IPv6 out there all over the place, but it's not like IPv4, right? We don't turn IPv4 routing on because, yeah, everybody's using IPv4. With IPv6, that's not always the case. And so here, what Cisco's doing is they're basically making it so that, hey, if you want IPv6 routing, yeah, we do that. However, you're going to have to turn it on. And so you can see here, we're trying to ping out to PCA, ACAD:1:3, and it's still not working. And what this probably means is we are going to have to take a look at PCB here. And let me take a look at the IP address config. I've got my link local. I've got the address. So why is PCB, and this is what I love to call fortuitous failure, right? Because we've got to dig back in, we've got to take a look at things, reassess. So why is PCB not able to ping? And let's do this. FE80::1. So there's my default gateway. Let's go back to the desktop. Let's go to the command prompt here. Let's ping, and now it works. But let me do this. Let's say no IPv6 unicast routing, because again, what we have to do here is we have to prove, is the router incapable of routing IPv6 unless we turn on IPv6 routing? Because again, remember, we could have made the argument there that, well, wait a minute, you enabled IPv6 unicast routing, then you figured out the problem was on the PC. You fixed the problem on the PC and it worked like you said it would. We put the right default gateway in there. But the statements you were making before that it wouldn't route IPv6 traffic unless IPv6 unicast routing was turned on, we're unable to prove that given the configuration once I fixed everything, right? So what I'm doing here to prove to you that the router will not route IPv6 traffic unless we turn on IPv6 unicast routing is I turned it off, and we knew that it was working before. And so now if I hurry up and sneak back over here and turn it on, we should see, hopefully, there we go, right? As soon as I turn on the router's ability to route that IPv6 traffic, it's going to work, right? So I want to make sure I took a step back, we broke it so that I could show you that it wouldn't work, and then we fix it and show you that it does work. All right, so we're going to save the running configuration to the startup configuration, right? Always a good thing to do here in Packet Tracer, as well as and more importantly in the real world if you're making some big changes. Now we're going to set the clock on the router. Now it's asking us to use that question mark command to see, well, how would I set the clock? Well, you can see right up here toward the top, we've got this clock command, and we've set the clock, right? So we know it's going to be clock set. And what throws learners here is that we're not doing this in global config. And again, I remember when I first learned how to set the clock, and I still remember trying to run the command in global config mode and like scratching my head and then like, oh, right, I've got to go to privilege exec. So I would go ahead and type end to get to privilege exec, and then we can set the clock. Now remember, by default, it's going to be setting the clock time to coordinated universal time, or UTC time. And I'll talk about that here in a second. So what is the UTC time? Well, right now it's plus 5 hours from East Coast time. And so if I look up in the right-hand corner on my Mac here, I can see it's February 14th at 10:05. And so let's try to catch it at 10:06. So I'm going to say 15, right, plus 5, 06, colon, 00. Then it wants the day of the month, it wants the month, and then it's going to want the year. And I hurried up to get that in there so that as soon as my clock rolls to 10:06, we're synced up here now with a good clock and a good time source. So how do we see the time? If I say show clock, that's the time. And again, you might be wondering, well, what was the time before we changed? If I come to the switch and say show clock, you'll see that this is kind of the sort of default time that we get when we have a new Cisco switch or a new Cisco router, right? We open the box up, we turn it on, and this is the time. And again, there's that UTC time. You'll also hear this referred to as Zulu time. The asterisk means that it is not an accurate source, right? That it hasn't been set, that it's just using the hardware clock. If I say show clock detail, right? These are some neat commands to work on. It's using the hardware calendar on the clock, meaning it has not been set. Over here, when I say show clock, the little asterisk is gone because we set the time of the clock. If I say show clock detail, what is the source of the time that we're using? It's no longer the hardware clock, it's user configuration, because we said clock set, we set the time. And these are little semantics that you will run into as you start to work more and more with Cisco devices, and maybe even in the environment that you're in today, if you're in some sort of a networking environment. So the time source is user config. We've got that sorted out here. And you might be asking, well, why is that important? Well, think about your log messages, right? And maybe if you're logging messages on the router don't have accurate time, you're not going to be able to figure out when an issue happened, right? Maybe a port went down and then came back up. You want to know when that happened. All right. And this also goes back to that service timestamps command that we saw in an earlier activity that we weren't very clear on. So what do I want my timestamps to be in my log messages, right? So if I say service timestamps log, you can see here we can do date time and milliseconds, right? Now, not a whole lot of options available there. On a real Cisco switch, you would see you can do local time zone. If you set the time zone, you could do in addition to the date time, you could do uptime, which I don't recommend that you do. And that would show time in the log from the moment that the router was booted up. So you wouldn't want to do that. But again, this is good for us to get started here. How do you see the log? Again, you say do show log. Do show logging. Whoops, typos there. And here's our logging. And again, we don't have anything being logged to our buffer on the router right now, and that's okay. So now we're going to ping PCB from a command prompt window on PCA. Well, we just did the opposite there, right? Kind of freelancing it. But let's go ahead and try to do that. Let's say ping 192.168.0.3, which I believe is PCB. And you can see we can ping it. Can I get the ping 2001:db8:ACAD::? And again, I could have put 0. I could use 2 zeros, 3 zeros. I could put all 4 zeros, right? Because that's implied. Or I could have put no zeros in there, right? Remember, if it's all zeros in the hextet, it's implied that it's all zeros. All right. So all of the pings are working. Configure the switch. Well, we've already configured the switch, so we might be a little bit ahead of where we're supposed to be here. We assigned it a domain name. We disabled the DNS lookups. And again, interesting. So while we've been talking here, I've actually booted up a real Cisco switch. So here's a real Cisco switch. And let's go ahead and say show run include domain. Let's see if it's set. That no IP domain lookup. And it is, and there it is, right? So the switch does keep it. I think over here, when we don't see that, if I was to go into global config and say no IP domain lookup, and then end, and let's even save the config, and let's say show run. Oh, and of course, now it shows up. So yeah, it does show up there. So, and I have to go back and look, see which commands I was running to see if I'm actually seeing what I think I'm seeing, but it's there. Okay, so configure and activate the VLAN. We did that. We've got the default gateway on the switch. We saved our running config. And so now we've already tested end-to-end connectivity, but we never tested from our switch. So now I'm going to ping 192.168.1.3. Can I ping PC1? I can. Can I ping PCA? Can I ping PCB? And we've got that ARP packet that goes out, right? That address resolution protocol packet, which is our little dot here that we missed that first ICMP packet because the switch has the layer 3 information because we're giving it the layer 3 information. But it needs the layer 2 information specifically for its default gateway. Show IP ARP. And you can see now we have that information in here for that default gateway, 192.168.1.1, where prior to running the ping command where we were getting the dot trying to get over here, we might not have had that information in there. And again, do I need a default gateway to get to PCA? No, because I know PCA's address right there. I know the layer 2 address. It's in my ARP cache. So then I can go ahead and put together a correctly formatted frame and send that traffic. All right, so now we're going to display some device information. We're going to use show commands to retrieve interface and routing information from the router and the switch. And so step 1, it wants us to take a look at the routing table here on the switch, or I'm sorry, on the router. And so we would say, let's get out of here, show IP route. And there's my routing table. So what code is used in the routing table to indicate a directly connected network? It's the C, right? And you can look up here into the little legend that we have for the codes and sort of the secret decoder ring up here. And you can see the C stands for connected. How many entries are coded with a C in the routing table? So they kind of give you the answer in the very next question, and that is 2, right? The 2 directly connected networks to which this router is connected. What interface types are associated with the C codes? Well, we take a look here. You can see directly connected, and it's Gigabit Ethernet interface types, right? Gigabit Ethernet 000 and 001. So now we want to use the show IPv6 route command to take a look at the IPv6 routing information. And it just, as is run that command, right? Because again, staying connected, the IPv6 networks obviously are numbered different. However, they're connected to the same interfaces, right? These directly connected interfaces, and we see those 2 entries. And we get, the table comes out in a little different format, as you can see here, right? So we got 2 lines versus for the directly connecteds versus the sort of the customary 1 line. And this is just how the output comes out. All right. So display interface information on router 1. So how can we do that? I can say show IP interface gig 001, and we're going to get all kinds of information. Let's give ourselves even more room with which to work here to see if we can squeeze it all into one window to look at. All right. So what information can we get from the show IP interface command? So what's the operational status of the interface here? Well, you can see the operational status is it is up, right? What is the MAC address of the gig? Well, that's going to be the burned in address. And so if we look through here, you can see the internet address. That's the IP address. We can see the broadcast address. And as we look through, where do we see the MAC address here? Or do we see the MAC address for this interface? And remember, this is a command we've run before. So they have us run the show IP interface command, and it shows us this information, but do you see the MAC address in here? And the answer is the MAC address doesn't show up in here, right? Shows us the broadcast address. So how is the internet address displayed in this command? Well, it's displayed in the CIDR, the classless interdomain routing notation. And I think the lab when it asks you what the MAC address is, what it's really hoping that you do is that you look at this and see, yeah, I don't see this in here. I see address determined by setup command, but I don't see a MAC address. But if you say show interface gig 001, here is where you would see the hardware type of the address, and then there is that burned in address, the layer 2 address, the MAC address, 48 bits, right? Because remember, this is hexadecimal values in here. And if, like we were talking about the IPv6 addresses, if there's 4 hexadecimal characters there, how many bits? Exactly. Each hex character, remember we did our conversion from binary to decimal, from decimal to hexadecimal, that each hexadecimal character is 4 bits. If you have 4 hexadecimal characters, you have 16 bits. So 16 plus 16 is 32, plus 16 is 48. That's where you get the 48 bits for the MAC address. So that's how you would have to get the MAC. For the IPv6 information, right, we don't see any of the IPv6 info. We'd have to say show IPv6 interface, Gigabit Ethernet 001. And here, excuse me, here you can see line protocol is up. So there's our status there. IPv6 is enabled. It gives us our link local address right here. And here's our global unicast address. Now, one of the cool things about IPv6 is I can have multiple, and again, with IPv4, you can do secondary addresses. But with IPv6, I can have multiple IPv6 addresses on the same interface. Meaning, if I was to go into router 1, and let's do that, and let's go into int gig 001, I can say IPv6 address 2001:db8 :ACAD, and they've got to be different, right? So I can say colon, we'll start with 5:1/64. And then I can come in here and say :6, right? There's just different subnets possibly, :7, :8. And the reason I'm putting a few of them in here is because now we're going to go back and we're going to run that do show, we're going to get out of here and we're going to say show IPv6 interface gig 001 and take a look at all the global unicast addresses that I've got on here. All right, this is something that you could put a secondary address on an IPv4 interface, but you can't do something like this, right? And then I can keep adding these if I want. All right, so display a summary list of the interfaces on the router and the switch. Well, we know how to do that. If I was to say show IP interface brief, right? That gives me the consolidated version there. And the same thing is true for IPv6, right? And again, you just change the IP to IPv6. And then on the switch, it's the same command, show IP interface brief, show IP interface brief. Now, these are great commands, right? And especially when you're working on switches with lots of interfaces, a 48 port switch. If you only want to see which interfaces are up or have a layer 1 or a layer 2 status that's up, I would say show IP interface brief, include the string UP. So a lowercase u followed by a lowercase p somewhere on the line, and only show me those. And the same is true. I can say, okay, well, I just want to see the interfaces that are down right now. Because maybe you're checking to see, hey, do I have any available interfaces on this router? Okay, well, yeah, it looks from here that there's a lot of available interfaces I could plug into, right? So reflection questions. Is the gig 001 interface showed, if it showed it was administratively down, what command could you use to turn the interface up? Well, that would be the no shut command. What would happen if you had incorrectly configured the gig 001 interface on the router with an IP address of 192.168.1.2? So again, so they're asking us here on the router for the interface gig 001, what if I had put .2 there? Well, the router would still work. It wouldn't crash the router, right? But PCB, which thinks that its default gateway is oh wait, I'm sorry, gig 001 I believe is on, I'm on the wrong side I think here. Yeah, to switch one. So what would happen is over here, we're concerned about the switch in PCA now, because if I change that interface's IP to .2, what would happen? Well, the first thing that we would notice is that we would have conflicting IPs because the switch is using .2. So that's the first problem. The next problem is PCA, who's looking at its default gateway and thinking, yeah, my default gateway is 1.1, now no longer points to the right default gateway, right? And we could say it that way, or you could say that it points to what the right default gateway should be, but router 1's got the wrong address, right? So you could look at it both ways. However, let's see what happens here if I do that on router 1. If I get into int gig, and this is something that, hey, mess around with these things, right? Experiment, see what happens here if you come in and say IP address 192.168.1.2. And take a look, right? Because now you've opened, through inquiry, you've opened yourself up now to investigating this. Wow, okay, hey, well, this is interesting here. I get this syslog message here. And keep in mind, right, we've got that date time format. Did I set the clock on the router? And you can see here that we did, but it's giving us that asterisk there, right? Which you might be asking the question, well, wait a second, do show clock. You said we shouldn't see that. We don't. We see it in the log messages, and now we should have some log. Thinks it's. And again, we're not trapping the logging information. If you wanted to capture the log information, right, and let's go ahead and play this scenario through. What I could say is logging, and let's see if it asks me, oops, get out of interface config mode. Logging and buffered, and we'll set it to, and again, the default, you can see it's going to be about 4,096 bytes. So let me set it to 8192, just so we have something different. And then I can say logging trap, and this is what level of messages, and by default packet tracer does 7, so we'll say debugging. So it means it's going to get everything. And then we would say logging. For the buffer, we don't need, these are other logging commands. I could turn logging on. I could log out to a host, right? A SolarWinds server, a What's Up Gold server. And let's say it's 192.168.1.222, right? So I could log messages out there if I had that set up. So again, these are just some commands that you could run to get your logging set up. But what I'm trying to do here is we'll go ahead and say IP address 192.168.1.1. And now the address has changed, but now I want to change it back so that we see that log message mistake, or that syslog message that I'm hoping would be generated here. And it looks like, of course, packet tracer not going to cooperate with me now to give me that duplicate do show log. And we don't have any messages being logged to the buffer. So again, this is packet tracer not cooperating with me here. What we would expect to see is those log messages that we saw earlier here telling us we've got this duplicate IP address, that those would go into our buffered logging, right? All right. So the last question we have is a question out of the description for the activity. In another, if another switch 2 was added to the router 1 gig 000 interface without an IP address on VLAN 1, what would the default gateway be for switch 2 to be remotely managed from PCA? And this is worth 5 points. And so the question is, and let's go ahead and play this out, right? Let's delete that connection there, right? Why not? Let's delete that connection. Let's drag a new switch out here. And the question is, if a new switch, and let's go ahead and so that we're talking, I got to wait for it to boot here. We're going to connect this new switch up here. And we're going to go from gig 000, and we'll keep it the same as the switch port was on the other side, which, let me look at the addressing table, fast Ethernet 05 to the router, and then fast Ethernet 06 to the PC, right? Now, what's interesting here, right, is I've just put this new device in here, right, which it's booted, so let's go ahead and put in here switch 2. There we go. We'll get to the CLI. All right, so we've got switch 2. It's all booted up. Spanning tree is going to do its thing. And the question is, we've added this new device in here, switch 2, to the gig00 side. And it says, give it an IP address of 192.168 for that interface VLAN, that switch virtual interface, IP address 192.168.0.2. Right? And the question is, let's no shut it. The question is, what would the default gateway for switch 2 be to remotely manage, to be remotely managed from PCA? And so in other words, this is a default gateway question. We've already set the default gateway on switch 1. The question is, we haven't done it on switch 2. So from PCA, if I was to come over here to my desktop and ping 192.168.0.2, the ping is not going to work. And the question is, why is that not working? And it's not that the ping's not getting there. The ping is definitely getting here, and switch 2 sees it, and switch 2 says, okay, it's time for me to respond back. So it looks at the source IP field of this ICMP packet when it gets over here, and it says the source is .1.3. The source is PCA. So it puts together its ICMP echo reply, and it puts this in as the destination, right? Because it's the source when it gets here. But for switch 2 to respond in kind, it now changes the packet, actually crafts a new packet, and puts in this is the destination. But what's the problem on switch 2 right now? Switch 2, and you could even say, do show IP route. There is no routing table. It's a layer 2 device. Switch 2 has no idea how to get to the 192.168.1.3. It can't get to PCA. It doesn't know how to get to that network. And we'll say, Control-Shift-6. And it can't get to switch 1. It has no idea how to get to the 192.168.1 network. It doesn't know how to get there. We need to tell it. Remember, this is traffic that's being generated by the switch, control plane traffic that we are generating on the switch. So therefore, we have to tell the switch, hey, if you're trying to ping or telnet or SSH somewhere and you don't know how to get there, do exactly what PCB is doing. Throw the traffic over to router 1. And router 1, 192.168.0.1, is probably going to know how to get there. It's a router. It's a layer 3 device. So we come on to switch 2, and we... And hold on one second here. I don't want to do that. There we go. Wanted to get out. So now we say, can we get to the 192.168.1.3? Can I get over to PC3 now? Or so PC3, PCA. Can I get to PCA now? And so we ping 192.168, and let me make sure that I put the right value in there. Oh, yeah, 0.1, and that should be do show IP interface brief. And yes, 192.168.0.1. And let me make sure I'm doing the right thing here. 1.3. Wait a minute. Okay, we've got the IP address in there. So we have a little troubleshooting. Show IP interface brief. Because, right, so that's the IP address of the switch. We'll do a show run include default. That is the correct default gateway. Can I ping my default gateway? 192.168.0.1. I can ping the default gateway, so we're good there. Can I ping PCB 192.168.0.3? Okay, I can ping PCB. So if I can ping those, I should be able to get over to, ping 192.168.1.2. Okay, I can. Well, maybe it was, or am I getting the right? What is the address of PCA? Do I not have the right address over here? I do, and I have the right default gateway. So the question then is, why is the traffic not able to get back to me? Because that should be working. I mean, if I can ping switch 1, oh, did I leave the wrong address? Of course. So, of course, as I jumped into the next thing, what's the problem? Yeah, we've got duplicate IPs. So the default gateway address on the router for PCA's network over here on the left-hand side, that default gateway is bogus, which raises the question, how am I able to ping switch 1? So let's, and again, might be messing with packet tracer here a little bit much. So interface Gigabit Ethernet 001, which I'm going to double check here, is the interface on that side, gig 001, and we're going to say IP address 192.168.1.1. And now, again, right, great to get in here and do a little bit of troubleshooting. Now we can ping PCA, right? PCA works. Can I ping PC, or can I ping switch, switch 2? I'm sorry, I'm pinging switch 1. Can I ping switch 1? I can ping switch 1. How we were able to ping switch 1 before that is a great question. Again, probably a little quirk in packet tracer. So now you save your activity, upload this activity, and we are done. All right, we covered a ton of ground here, right? But some really good stuff. And that is going to do it for Lab 10.4.4, building a switch and router network. Thanks so much for watching, and I hope to see you in the next video.